on the same set of axes of page 4. Okay. And then find the value of R and S and do part 2 as well. Okay. And I give you about 4 minutes now to do B part I and part 2 before I run through part 3. Okay. Give you 4 minutes. part, you can refer to draft paper. Okay, maybe you can write it down in your notebook just as a reference, so that when you revise, you know where to put things. Okay, what we're going to do today is to learn what is the equation of a straight line. I will tell you in a moment what gradient means. And the value C is a number, okay, that tells us the y-intercept. Okay, so what exactly is gradient and what exactly is y-intercept? Okay, gradient actually refers to the steepness of a slope. Okay. So with different numbers, it tells us there are different steepness. Okay, so we have a way to measure this steepness. So for example, you go and climb your Bukit Timah hill versus you running for 2.4. What is considered steep, what is considered not steep or gentle. Okay, and just by talking about steep and gentle only is not enough. We need to have a value to really give an accurate measure of gradient itself. Okay, so that's why we have this idea of gradient, which is a measure of the steepness of things. What about y-intercept? What does y-intercept actually mean? It means that it is the number or the value, okay, where the graph passes through the y-axis. Okay, so for example, just to illustrate it, okay. So for example, if I have a straight line that cuts like that, okay, y-intercept actually refers to this number, okay, that appears when your graph passes through the y-axis. So this thing itself is the y-intercept. So from whichever way that we name the graph, okay, we have information that we can collect. For example, okay, Dylan, he is being named not just Dylan, he is named Dylan Ling. Okay, and from the name itself, we can tell that his surname is Ling and therefore his family roots lie in the Ling heritage. Right or not? Okay, so that is the way, okay, that names work. Okay, I don't know why it's my professor. Okay, so that is how naming works. So therefore, in mathematics, okay, we need to have such information as well. So y was mx plus c. Knowing f will tell us the gradient. Knowing c will tell us the y-intercept. So example, if I have an equation that is y equals to 2x plus 3, okay, and understanding the format of how names or graphs are being formed, right, with the equation itself, we can will be 2. The y-intercept will be 3. Okay? Another example, if I have y equals to 7 over 5x plus 3, okay, maybe not 3, okay, plus 6. Okay? If I compare this with the format that we know, gradient will be 7 over 5 and y-intercept will be 6. Okay? Another example. What if I have y equals to negative 5x plus 4? Okay? Then the gradient. Okay, we must know that negative numbers are still numbers. So the gradient will actually be, in this case, negative 5. Okay, so gradients need not always be positive numbers, neither must it be whole numbers. So like we saw here, it can be a fraction. Okay, so gradient is negative 5, and then our y-intercept is equals to 4. Okay, and then another one, what if we have negative 2 over 3x minus away 5 over 4. Okay? How will the gradient and the y-intercept be determined? Gradient will be the number in front of the x, that is negative 2/3, and y-intercept, okay, will actually be negative 5 over 4. Right? Why? Because we must know that y-intercept, okay, is referred to the plus c over here. In this case, we have a minus sign. Okay, so we take the minus sign along with us. Okay, we must be a negative number, hence we get negative 5 over 4 as our y-intercept. Questions? Okay. One final example. What if I have an equation of a straight line that is y equals to x? What do you think the gradient will be? Let me call out a name. This idea called yesterday. Weird. I think it's Velda. Yeah. Velda, can you give this a try? What is the gradient? What do you think the gradient will be? Sorry, speaking anything. Just abbreviated. What's the gradient? Sorry, nothing, 0. Nothing means 0, is it? Okay, so the guess that Velda has is that gradient is 0. Would anyone want to suggest something else? Okay, yes, we have. 1, okay. So go try. Okay, just running go. Alright. So in this case, okay, what exactly does x mean? Okay, we already mentioned that x actually means 1x, right? We do not need to write 1x. So actually the gradient in this case should be 1. Okay? It's not that because there is no number, it means nothing, so it becomes 0. It is not all the time that nothing is 0. Okay? So it's a abstract concept, right? I finish this one first. Okay? And then for y-intercept, okay, y-intercept itself, unlike our previous example, we don't have the plus something or minus something. Okay? So in this case, our y-intercept itself, okay, it is truly nothing and it is actually a 0. Okay? Because there's nothing what? It must be a plus 0. Can it be a plus 1? If it's a plus 1, it must be there. Agree? Okay? So it must actually be a 0. Okay? Questions? Alright? So yes, we have to go about it now. Okay? Then, now, sorry, maybe before this is the last one. Okay? Another one now. What if I give you y equals to 3 minus away 2x. Okay, I give you y equals to 3 minus 2x. What will the gradient of the y-intercept actually be? Okay, let's try calling out a number. Mika. Okay, who wants to answer? Okay, but you might understand like that. Yeah. Okay, so everyone can tell us what do you think is the gradient? -2. Ethan, what do you think? Because by right you're supposed to also be last, right? Because you have 10 models in later step. So let's decide. You see -2 and then Ethan, what do you think? -2. Sure or not? I mean, it's not getting correct, right? Yeah, it's not right. Huh? Okay, Kevin can sit down. Kevin say -2. What do you think? -2. Do we all agree that -2? How many of us disagree that -2? Okay. Alright, let's go back to what we understand. M is supposed to be gradient. It is a number that is where it is in front of x. It is the coefficient of x. Okay? So it is not that the first number that appears is the gradient. It is the number that is in front of x that is the gradient. So therefore, Kevin is right that the gradient is -2. Understand? Okay? So, okay, +5, +5. Okay? Therefore, this leads us to our y-intercept. What will our y-intercept actually be? Call another name. Jude. I think Jude is the last one to stand. Okay? Jude, can you tell me what you think is the y-intercept in this case? 3. Positive 3 or -3? Positive 3. Do we agree with that? Yes, huh? Yes. What? Okay. You want to say -3? Okay? So, we always recognize the positive or negative based on what's in front, the sign is in front. We don't see that this is a negative number because of what comes after, right? So therefore, our y-intercept, yes, it is a 3 and it is a positive 3. So we need to be very clear about what is gradient and what is y-intercept. Okay? Gradient must be the number in front of x or the coefficient of x to be precise, and your class C or your y-intercept, okay, must be the constant number without variable. Okay, without any variable, because sometimes it may not be x. Okay, it can always be some other variable, maybe h and t. Okay, so are we clear about this? Yeah. Then moving on, give another example. Questions? Someone calling me? No? Yeah. Sometimes I'm very freaked out that I hear something and then actually no one's calling me. I don't know when I should get myself checked. Okay. So now let's look at another kind of question that you must know when it comes to equation of a straight line. If I give you the gradient, okay, to let's say be 5 and the y-intercept to be 2, what do you think is the name that must come out of it? Okay, yes, Mimi.
Y equals to 5x plus 2.
Yes, y equals to 5x plus 2. Okay, so if you're given the gradient and the y-intercept, I must be able to piece it up together that m becomes 5 and c is actually a positive 2. So it is 5x plus 2. Okay? Another example. Okay, since you asked for more, can you give me a number for gradient? Any number?
9.
Huh?
69.
10. Okay? Can it be that? So what do you think?
Yes.
10 what? 10 ah? Can you give me a super high number for y-intercept?
3672 or 0.5.
It's the same thing.
3672.5. Negative sign. 3672 and a half. Okay. So then, since you created this question along with Dylan, what do you think is the equation going to be? Okay. Dylan, you agree with this answer? Okay. Is it not simplified already? How else do we want to write it?
How would you want to simplify it?
So y equals to 10x plus 3672 over 2. Are these two numbers the same? No, yeah. I sincerely think that the kid is getting to you because of the jacket and your marriage. You don't feel anything in the jacket. Okay. Mr. Tan really said that wear PE, but I hope that you all can wear half you doesn't mean you continue wearing jacket. Then it contradicts the idea. Then I think you don't deserve to wear PE attire. Okay? Or rather half uniform. Okay? So, what? Oh yes, thank you for it. This one not right, okay, I think we're all clear with that. Okay? Then, another example. Okay. Maybe Kate, can you give me a number for gradient? Any number. Don't want positive anymore. Yeah. Negative 6. I don't want a 69, I want 6.9. Okay, because I need two numbers already. Okay? So, then your y intercept. The same number. Okay? 375.4. Yes, okay. What do you think the equation will then be? Negative 6.9x plus 375.4. Okay, so thank you Kate and Marcus for giving me the numbers. Okay, I want to ask, is there an alternative way for us to write this equation? Instead of saying negative 6.9x plus 375.4, how else can I write it?
69 over 10 plus 375.
Yes. Okay, so 375.4 minus away 6.9x, right? So that's also another way of writing. Okay, so I want us to be very clear about how we can write equation. Now, one very important thing, okay, I don't think we need more of such questions already. Okay, is that important thing, equation, okay, as the word suggests, equation must have what? Equal sign. Okay, so it must have not just equal sign, but it must have a header. Okay, in this case it is y. So you don't just tell me 5x plus 2. Okay, 5x plus 2 is not an equation at all. Right? You must make sure that it's complete, okay, as the entire statement itself. Okay? Understand? Hope that we're clear about this. Okay? Now, next. Continuing in our textbook. Okay, we're going to learn about gradient. So we have already covered equation of the straight line. Okay, next thing is about gradient itself. So as I mentioned earlier on, gradient is a measure of the steepness of a slope. I know that some of you have tuition and your tuition teacher or your tutor, okay, has given you a formula, right, to learn how to find gradient. Okay, something like that. Okay? Alright, if your tutor has taught you this, okay, I am not going to use this because you will be learning about this when you're in Sec 3. Alright? So, what I want us to learn instead is simpler. We learn that gradient works with the formula of rise over run. Okay? What is rise and what is run? So when we're given a graph itself, okay, x with the axis, x and y and 0. Okay, if I have a graph that looks like this, what exactly is rise and what exactly is run? I will have to know and find one point on the straight line, okay, that is easy to read, and another point that is on the straight line that will be easy to read, and make sure that I can form a right angle triangle, okay, because our rise is determined by this and our run is determined by this. Okay, what do I mean? It is the number of units, okay, for the rise over here in the triangle and the number of units over here. Okay, so that is how we find out what is gradient, rise over run. Okay, just like the word suggests, rise, the sun rises, okay, from east to west, okay, going upwards, going downwards. Run itself, you run on the straight path, so it must be the horizontal segment itself. Okay.
You miss your whole second.
Was there a paper that flew out?
Yeah, I wonder.
Miss.
Okay, so when it comes to gradient, the sign actually matters. Just now we would have seen that different questions have different signs. Okay, sometimes it can be negative for gradient and sometimes it can be positive. What does that actually mean? It actually means the way that the direction is going to be like. So if our line is going up like that, okay, I see this as going up because we always see things from left to right, just like how we read a book left to right. Okay. Marcus, don't make yourself ridiculous. Okay, so sign of the gradient itself, for graphs that are upward going like that, okay, your gradient value or the sign itself is always positive. So it must always be a positive number. Okay, and when your graph is actually downward sloping like that, your gradient is negative. Okay, it can be any number so long as it's a positive or upward sloping. And then it is downwards and negative, okay, for downward sloping. Okay, just like for example, in the graphs that we drew on page 4, we have one that is going upwards, okay, which is example, your y equals to 6x. And then the one that is going downwards is your graph of y equals to 2 minus 4x. Okay, so this one we can tell that the gradient is 6. And for this, our gradient is negative 4. Right? Otherwise, you don't deserve your labor day. Okay, label by way of
Row 1.